Hi students, this is Ilangovan, Professor of Zoology. Today I would like to explore and explain some of the concepts related to biodiversity. See that one, in this world we have a number of individuals. One individual is different from another. Say an example, from amoeba to the largest blue whale. See the amoeba unicellular and microscopic. If you take the whale, it is about 30 meters long and weighing about 120 tons. So there is always discrimination and differences between one individual to another. So there exist differences among the individuals of a species or genus. Accordingly, they also adapt to various environmental conditions, namely the habitats. So the diverse adaptations that can be seen in the case of animal groups can be referred as what is called biodiversity. So in this world you can see, if you are taking ants alone, there are 20,000 different species of ants, 28,000 species of fishes and nearly 3 lakh species of beetles. Even if you are taking the same organization, one animal is radially symmetrical, another one is biradially symmetrical, and some more organisms bilaterally symmetrical. Even if you are considering the body temperatures, some can withstand it, some can just maintain a constant body temperature. For example, these are all the regulators, the animals. And some others cannot maintain a constant body temperature. And these animals are called, that one cold-blooded animals or hyperthermic animals. So you could see differences either in symmetry or in the mode of nutrition or in the place of living or habitats, or even, for example, the germ layers, the nature of the coelom they possess. In all cases, there is always a degree of differences among the individuals, between species, between genus, or even at different levels of ecological communities. And all these differences can be called together as biodiversity. And I have represented in the slide also the existence of different forms of a species or a genus and diverse adaptations for various environmental habitats, and that is called biodiversity. And regarding this biodiversity, one sociobiologist by name Edward Wilson, he popularized this term in all biological levels of organization that becomes famous. And as per the rule, that one person by name Robert Mead, he just observed the global biodiversity of species around 7 million. But it was in 2004, if we are taking as a count, as per IUCN, there were about 1.5 million species. But as per the statistical data at present, there is a species diversity in the global diversity of nearly about 7 million species. Now, when you are talking about biodiversity, we have studied already in case of botany in the previous classes. We are considering this biodiversity at 3 levels. One, genetic level, another one, species level, another one, ecological level. So the first one is called the genetic diversity, the second one, species diversity, and third one, ecological diversity. So the genetic diversity is based on the genetic level. For considering a different species, say an example of insects alone, the insects occupy nearly 70% of the total animal populations. And if you are taking rice variety in India alone, there are nearly 50,000 genetic varieties. There are different varieties of rice. Genetic varieties of rice. Even if you are taking basmati rice alone, we have more than just 27 species of basmati rice. So when we are considering the diversity at the genetic level, then it is called genetic diversity. Now species diversity. So it is being considered at the species level. If you are taking a particular species, say an example of frog. So frog there are different species of frog. One is different from another. So this is based on actually the species level. And for example, in the case of Western Ghats, the species diversity is always greater than there is Eastern Ghats. That means the Western Ghats normally have greater diversity, greater species diversity than the Eastern Ghats. So what is the reason for that one? The reason for the Western Ghats having more species, mainly the climatic conditions. And that one, again, the Western Ghats mostly not disturbed by the climatic conditions or the natural calamities when compared to the Eastern Ghats. So in the Western Ghats, the conditions are best suitable, and the Western Ghats are not normally just disturbed by various environmental situations. That is why the species are growing well. Even you can give, for example, if you are comparing the polar regions with the tropical regions, we have more biodiversity in tropical regions than in polar regions. The diversity being decreased from tropical regions towards the polar conditions or polar regions. And one example, the Amazonian rainforest in this world, the Amazonian rainforest in this world has the greatest biological diversity. That is one of the places, the most important place in America, in United States, having greater biological diversity. So this is the reason why we have more species diversity in Western Ghats than the Eastern Ghats. It is not being disturbed by environmental conditions and also the weather conditions, and the climatic conditions are best suitable for the animals and plants to survive. That is why the species diversity is greater in Western Ghats than the Eastern Ghats. Then ecological diversity. So it is at the level of ecology or ecosystem. So the genetic diversity at the genetic level, the species diversity at the species level, now the ecological diversity at the ecosystem level of organization. Suppose we are comparing two countries, India and Norway. So we have different ecosystem levels. For example, the desert, the wetlands, the coral reefs, then even the rainforest. So normally the rainforest, the tropical rainforest, show great diversity than the deciduous forest. This is because of the climatic conditions. Now, so ecological diversity is based on the ecosystem level, what I mentioned earlier. If you are comparing the country Norway with that of India, India has great diversity at the ecosystem level than Norway. So these are some of the actually relativeness towards the diversity, either genetic diversity or species diversity or ecological diversity. Now, we have just actually seen so many summits have been organized by the United Nations organizations. So the United Nations of America conducted a number of summits. For example, the International Conference on Human Environment, or we have the Earth Summit, or World Summit on Sustainable Development, and they were being held in different places. For example, Stockholm, or in just Rio de Janeiro, or in Johannesburg, in Africa, in South Africa. So, while we are talking about this one, all these conferences and summits normally stress the importance or the significance of biodiversity and also and its conservation to ensure a normal, sustainable life. So that is the main importance of the different summits and conferences undertaken by or being actually was held by the United Nations of America. So we are talking about the systematics. So what do you mean by systematics or taxonomy? So if you want to know the biodiversity, you have to know something about taxonomy. The taxonomy is a field of science. That is the one which gives about a perfect idea about the biodiversity. That is why we have to talk about this topic and this biodiversity as per the syllabus we have. Now, what do you mean by systematics? This is another term used for taxonomy, the study or classification of organisms. So we have a number of organisms I mentioned earlier, from starting from unicellular to the macro level, namely there is blue whale. In all cases, we want to categorize the organisms, we want to make the study of different organisms in a simple way. We have to group them, and that grouping of organisms is called what is known as classification. Such a study of classification of organisms, either animals or plants, is known as systematics or taxonomy. Now, let's go far. Some of the people contributed towards the field of this taxonomy, and for that we have to know the history of taxonomy. So it was Gerald Simpson, and he considers such systematics or taxonomy as the diversity of organisms and all their comparative and evolutionary relationships. So he was the man who even introduced what is called the evolutionary species concept. He just actually has given the idea that there is a common ancestor and we have different groups of species, and one species is different from another species, and they have been derived from a common ancestor based on phylogenetic relationships. So the biodiversity is nothing but the systematics, or the systematics is nothing but the study of organisms and all their comparative relationships. In what way they are different from one another, how to correlate an insect with a scorpion, how far they have been descended, why are they grouped under the same category of Arthropoda. This is because of the evolutionary relationship, how far these organisms have been evolved from the common ancestor. So he just described on this concept, on this basis only, he proposed or he explained the systematics. Now Hippocrates, you know that one is called as father of medicine. He also contributed something towards the classification of organisms. He just classified the organisms in a crude manner. For example, he classified the organisms into fishes, those living in water, reptiles, the crawling animals, the birds, those living that is leading aerial mode of life, and also the insects, the only one group, and the invertebrata. This is a crude method of classification. And another person who is called as father of biological classification, the one he just classified the organisms based on the similarities and differences, the one who has projected his nose in all the fields of science, even in the field of embryology. The person is called Aristotle, father of biological classification. He is also considered as father of or founder of embryology. Then Theophrastus, he contributed much towards the botanical species or the plant varieties. That is why he is aptly called father of botany. But the most important person, a Swedish botanist, it was Carolus Linnaeus. He was the first person has given a correct idea about the classification. So he is the founder of binomial nomenclature also. And before his arrival, we used only the names, only the vernacular names, and he was the first person to introduce the scientific terms for the animals. He just developed the system of classification, what is called binomial system of nomenclature. And also he was the first person arranging different groups into definite categories in the form of a framework, and that is called hierarchical system of classification. So he classified the organisms in a definite order. In a framework, he explained the different groups based on a systematic framework, and that is called hierarchical system of classification, and that was developed by this fellow. Then now, and his work was actually published in two main important book volumes. One, Systema Naturae in 1758, and before that he introduced a book or published the book Species Plantarum in 1753, and before that also he contributed another publication what is called Genus or Genera Plantarum in 1735. In all these things, he just classified the organisms under a definite hierarchical system, either kingdom or class or phylum order. So he used the framework for categorizing the organisms into different groups And that is why that is what we have studied so far. The hierarchical system of classification, the stepwise system of classification was introduced by this person. Then it was the first time a person by name Lamarck. So he was the man introduced the term biology. So he used what is called phylogeny in systematics. That is, what is phylogeny? You see the evolutionary relationship with the organisms. How far the different groups of organisms have originated from a common ancestor and in what way they have differed from one another. So this system based on phylogeny or based on evolutionary relationships is called phylogenetic system of classification or cladistics. So what do you mean by a class? What do you mean by class? So it is nothing but evolutionary branches in it or branches in an evolutionary tree. Branches in an evolutionary tree. So he introduced what is called the evolutionary relationships for the classification of different groups of organisms, and he correlated the evolution with the interrelationships among different organisms. Then it was Michael Adams. He introduced what is called the phonetics method. What we call this one the numerical taxonomy. And what do you mean by a numerical taxonomy? In the case of numerical taxonomy, we are not considering the phylogenetic relationships, but we are classifying the different groups of organisms based on the similarities and differences. Based on the similarities and differences. So the differences and similarities are taken into consideration for classifying the organisms, and that method is called phonetics classification or phonetics taxonomy or numerical taxonomy, in contrast to Lamarck's phylogenetic system or cladistics. Then Sir Julian Huxley, he introduced what is called this newer biosystematics. Once again, there is nothing but actually classification of organisms based on the similarities without evolutionary relationships. Now, it was Charles Darwin, a familiar person in evolutionary concept, the theory, what he proposed, the natural selection theory, the book he has written, The Origin of Species. So in the Origin of Species, he has given a number of species, and the speciation could arise, and the speciation could actually take place because of environmental situations. So he was the first person that described actually the different species and how far the species originated, how far they adapted. So like that. So he is also one of the persons contributed towards the taxonomical science. Now, above all, recently, in the 20th century, Ernst Mayr, he is called the Darwin of the 20th century because Darwin has given a clear idea. There is always struggle for existence in all animal groups, and that is one of the reasons why we have developed different species based on the survival of the fittest. It is a nature which selects the right type of individuals, so that that individual pass on to the next category, the next level in an evolutionary ladder, leading to the formation of a new species. And that basic principle was later supported by Ernst Mayr. Hence he is called the Darwin of the 20th century. So he was a pioneer, you know that one, for the currently accepted biological species concept. When they are taking the species concept, we have different types. Biological species concept, evolutionary species concept, polytypic species concept. So in all these cases, we have different opinions and ideas. But the most accepted species concept was given by Charles Darwin. By name that's Ernst Mayr. Hence he is called the Darwin of the 20th century. And that is why I written also here, pioneer, currently accepted definition of biological species concept. So he was a person for origin of species diversity. According to him, he described the species in a simple manner, a group of interbreeding natural population. A species is nothing but a group of natural interbreeding populations. That means a species, one species is isolated from another species by reproductive means. That is called reproductive isolation. So the meaning for that one, there is no interbreeding or reproduction is possible between two different species, and and that is called reproductive isolation. So a group of interpreting natural populations, because we are using the word natural populations because species is not man-made. It is a natural entity. It is a natural reality. In all cases, evolution is operating only at the species level. Hence, Darwin has given importance for species, origin of species. He has given importance for the species level only. So, all species are natural populations. They are not man-made. They are reproductively isolated. There is no reproduction or breeding is possible between two different species. Now, he contributed much towards the field of the species concept, the biological species concept, that is the modern species concept, and the other categories related to this arena. He was awarded prizes just for his contribution. He received 3 prizes, and they together called the Triple Crown of Biology. So just a person honored by actually that is the entities. Now we are just for studying the biodiversity, we have to classify the organisms. What is the need to group the organism into different categories? We have a number of organisms, either smaller or larger, unicellular or multicellular, then constant body temperature or without constant body temperature, with the symmetry, without symmetry. So for such groupings, we need a classification. So what is the importance? Why we have to study classification? So it makes the study of wide variety of organisms what is said. The different organisms at different levels, starting from unicellular to multicellular level, and other levels of organization, the nature of the cell, etc. It makes the study of wide variety, a large number of organisms, that is easy. And also, secondly, it gives or projects a picture of all life forms, either from simple or to complex, either from simple or to complex. So all life forms in different categories have been explained only through classification. That's why we need only the classification. It projects a picture of all life forms at a glance within a single just note. And also it helps to understand the interrelationship between different groups of organisms. So why are actually the mammals are related to, that is the reptiles. How are the birds are related to the reptiles? And for knowing all these relationships, the interrelationships between different groups of organisms, between the same groups of organisms, in all these things we need a clear-cut picture, and that is being provided by this classification while studying the classification. Then again, so we can say, for example, nothing makes sense in biology without evolution. So evolution is the basic concept, and that is normally responsible for making the biological science normally a sensitive, a meaningful one. And now this taxonomy, from the taxonomy model that forms the basis, we can have the development of other biological sciences, either for example biochemistry or cytotaxonomy or chemotaxonomy. So the different fields of biological science have been developed, have been actually diversified based on only the taxonomy. That's why I written here, it serves as a base for the development of other biological sciences. Now, so we have different branches. So these are all some of the actually the importance of classification, why we have to study classification, why we have to give importance for classification, etc. Now, let's go for the different branches of systematics, that is taxonomy. So systematics, the word is given, introduced by some people, and taxonomy by some people, but both are having more or less virtually equal meanings. Now, cytotaxonomy. Now, this is a kind of classification based on the nature of the cell. What we are getting from the cell information, the cytological information has been used as a tool for classification. So, while we are using the word cytological tool, here it is nothing but the karyotype. You know the karyotype. The word karyotype refers to complete chromosomal constituent of a cell. Complete chromosomal constituent of a cell. So, Based on the karyotyping, we can classify the organisms. For example, for a particular organism, the chromosomal constituent is constant. Say an example, human being has 46 chromosomes with a different arrangement of genes. And similarly, if you are taking a dog or a frog or a parrot or just a wheat, in all cases, we are using the karyotyping, the cell structure, the nature of the nucleus, the arrangement of the chromosomes for the classification, and that is called cytotaxonomy. That is next to one, the different field related to chemo, just what is called the biological science, chemotaxonomy. It is based on the chemical constituents of a cell. So we have different chemical substances in the cell. The biochemical analysis showed that we have different kinds of proteins, different kinds of amino acids, even we have isoenzymes. So even the pheromones, in the case of some animals, the pheromones, some chemical substances are released by some insects in order to attract their opposite species, that is opposite sex. And these are all pheromones, hormone-like substances. And these chemical substances are also taken into consideration for classification, and that is called chemotaxonomy. Now, the next one, paleotaxonomy. So, you see that one, the paleontology, a study of fossils, the remains of the past. So, this field normally gives us an idea about the nature of the animals that have lived in the past. How far these animals could have gone, how far these animals have passed on. So these are all some of the things we want to know. If you want to know, we have to study the fossils, the key of evolution, the true witnesses of evolution. So the key to unlock the mystery of the Pleiadian past. So the fossils are the true witnesses of evolution, the direct documents of evolution, the key witnesses of evolution. And based on the fossil evidences, based on the identification of fossils, based on the dating of fossils, the duration of the fossil, the time of fossil, when they formed, that is called the dating, how to calculate the age of the fossil. So these are all some of the criteria being used under paleotaxonomy to classify the animals. Anyway, so it depends on the identification and then dating of fossils, that is aging of fossils. These are all some of the new fields of science, and what we are using in support of taxonomy, how to classify the animals, how to correlate the animals, etc. Now, so what are the basics in classification? So what are the steps to be considered, and what are the steps normally proposed by different scientists in classification? So on seeing a particular organism, we have to identify that organism, and that is called identification. After identification has been completed, one should give a specific name, a scientific name to that organism. That method of assigning names or giving names, here the names are not vernacular names, the scientific names to the organisms, and that is called nomenclature. Providing name and assigning name, namely the scientific names rather than that is vernacular names to organisms is called nomenclature. Once identification has been completed, once the name has been given, we have to group the organisms. That is called mode of arrangement of organisms according to certain plan. So we are grouping the organisms into different categories according to a systematic plan or order or arrangement. This is what is called classification. And this classification is purely based on the similarities and differences between different groups of organisms. So similar organisms are grouped under one category and others are included under another category. Now, for identification, for just actually comparing the organisms, we need a key. The key is nothing but a literature mentioned in a book. So, it is nothing but an aid, a helper we can say, used for the identification of animals and plants based on similarities and differences using the alternative contrasting characters. So, it is nothing but a key, it is nothing but what is called an aid used for the identification of any plant or any animal based on similarities and differences. Now, under this actually key, there are two types of key. One is called bracketed key. Another one, intended key. Intended key. So what is the difference between these two keys? Now in the case of bracketed key, suppose you want to differentiate two animals. We are taking only two alternative characters. We are representing character number 1, character number 2 or character number 3 or 4 and so on. But we are taking only two contrasting characters just to identify that animal. In the case of bracketed key, only two alternatives are taken. Now on the right side we are representing the number, and that number is the next alternative character to identify the animal. Suppose we are taking a frog and taking its character, 1 character, 2 characters. Suppose the nature of the skin. In some cases skin is more slimy, in some cases skin is less slimy. And these are the two contrasting characters. And here we are taking only two just contrasting characters for identification of an organism. Now in the case of intended key, a number of choices can be taken, a number of characters are considered, and we are comparing all those characters for the identification of an organism. And that is the main difference between bracketed and indented key. So in bracketed key, only two alternatives are taken for identification of an organism, and for intended key, a number of choices being given. So if you are just one character is not correlating with that animal, we are going for the next choice like that to identify that organism. So key is nothing but a for identification of an organism. Now the nomenclature. So different rules have been framed by authorities. So they have given a code for naming the animals, naming the plants, naming the viruses, naming the bacteria, and also the cultivated plants. So the naming of animal is monitored or governed by one ISSN, International Code of Zoological Nomenclature. So they have put forth some codes. On the basis of that, only one can give a name to that organism, name the animal. And similarly for ICBN, International Code of Botanical Nomenclature, and both are now situated in England, in London. And if you want to know anything about it, if you want to give a name to a new creature in bacteria, so you have to follow International Code of Bacteriology Nomenclature. It is also called ICBN. And similarly for virus, IUCN, International Code of Viral Nomenclature. Now they have introduced, so all are being commissioned actually under the control of International Commission of Nomenclature. International Commission of Nomenclature, even ICZN, is being governed by International Commission of Zoological Nomenclature. Now for cultivated plants, we have ICNCP, International Code of Nomenclature for Cultivated Plants, a new area what we have developed. So other than the natural plants, new plants have been developed by means of various genetic methods, either by means of protoplast fusion or by any other methods, and these plants are called the cultivated plants, generated plants, transgenic plants, all being given a specific name, a particular name based on the rules framed by ICNCP. Now, what are the universal rules of nomenclature? Suppose we want to give a new name to a particular organism. We have to follow certain rules. These rules are framed by this Code of Nomenclature, the International Code of Nomenclature. So while giving a name, the name should be in Latin. If you are handwritten, just it is being written normally. But when it is being written, that is when it printed, that should be in italics. So definitely the name should be in the language of Latin. So we are giving two names, for example. When I am taking the Frogrona hexadactyla, the first name or the first word always referring to the generic name. It describes the character. And the second one is nothing but the specific name or specific epithet. Usually the generic name is always a noun. The specific name is always an adjective. For example, use textilis. The textilis, the word refers to its economic importance. And Rana hexadactyla, The word hexadactyla describes one of its characters. Describe one of its characters. So one of its characters having what is called 6 digits. That is what we call this one hexadactyla. So the generic name is always a noun and the species name is always a specific epithet, that is nothing but an adjective describes one of the characteristics possessed by the organism. So if you are printing it, then you can write it just in italics to indicate the Latin origin. When we are writing actually using the hand, when manually written, the two names, the first name and the second name should be underlined in order to differentiate the genus name and the species name. Now, the next row. So I mentioned already the first word, the genus name. When I am writing, for example, Rana, hexadactyla. Now the first word is the genus, the second word is the species. See that one, the generic name always starts with a capital letter. In any case, the species name always starts with a small letter. That is, for example, here hexadactyla. Similarly, here at the end, this is the genus name starting with capital letter, and this is the specific name starts with a small letter, indica. Then, this is the rule framed by the international rule of or the code of nomenclature. Sometimes we should honor the scientist, the one who just has given the name for that organism. So, in order to honor that person, the name of the scientist who just proposed that scientific name should be written after the species epithet. Here, for example, Mangifera indica, the name of mango, and that was given by Carolus Linnaeus. That is why we have written the abbreviated form of the person Linnaeus. So this is another rule. Now, scientific names. So we have the vernacular names. The vernacular names actually different in different languages. Say an example of dog. In Tamil we call this one as Noi. In Hindi it is called as Kukka. In Telugu it is called as, actually in Hindi it is called as Kutta, and in Telugu it is called as Kukka. So there is a discrimination, difference in vernacular language. So it creates a lot of confusion. In order to avoid confusion, an organism has been given a scientific name. That scientific name just has either 2 words or 3 words or just even many words. Now the first method, the crude method adapted in the early beginnings, polynomial nomenclature. So here an animal or a plant was given many names. A series of words describe the characteristic features. For example, Caryophyllum, it has many words. That system of naming an organism by using many words is called polynomial nomenclature. But the most efficient method, what we are following at present, is a binomial nomenclature. So in this one, each scientific name has 2 components. The first component is the generic name, and the second component is nothing but a specific epithet. This method of naming an organism by 2 components is called binomial nomenclature, what I represented earlier, and that was given introduced by Carolus Linnaeus. For example, Mangifera indica, or we have, for example, frog, Rana hexadactyla, or any other species, Amoeba proteus, Plasmodium vivax, or Plasmodium malariae. So for each organism, we have 2 components and names. Now, again, so in the case of binomial nomenclature, the first word refers to the genus name and the second word refers to the species name. For some organisms at the level of subspecies, we are using 3 words. It is now in use, and that is called trinomial nomenclature. This method used 3 words for naming an organism. Say an example of crow. Corvus, splendens, insolens. I have given 3 words. The first word refers to the generic name. The second word refers to the species name. And the third verb refers to subspecies. Now, there are three different species of subspecies of crow. One is Corvus splendens insolens, Corvus splendens splendens, Corvus splendens protegatus. Now, this is based on the geographical isolation. In the past, we had the land mass united. There was only one type of crow, Corvus splendens. Because of geographical isolation, when the land masses were separated, for example, Sri Lanka separated by Gulf of Mannar or Myanmar. So, we had formed three different types of species because of the change in the genetic arrangement. Now, Corvus splendens insolens, a crow in Myanmar, Corvus splendens and splendens, a crow in India and Pakistan, Corvus splendens and protegatus, a crow in Sri Lanka. So, a subspecies level is also formed. This is also leading to speciation because of the geographical isolation. Normally, a species is formed because of reproductive isolation, but sometimes a subspecies level is formed because of the geographical isolation followed by reproductive isolation. So, this is an example for trinomial nomenclature. This is because of a formation of subspecies due to geographical isolation. Now, taxonomic hierarchy. I mentioned earlier, the hierarchical system of classification was introduced by Carolus Linnaeus. So, we have to arrange the organisms in a definite order from higher level to lower levels. For such an arrangement, we need a framework. That framework normally used to assign organism, assigning an organism in an appropriate place at its place in a systematic framework of classification, and that is called taxonomical hierarchy. So, for arranging an organism at its appropriate place in a particular systematic framework, we need a taxonomical hierarchy. So, this is nothing but stepwise classification of organisms starting from upper level to the lower level. Starting from the upper level to the lower level. That means in the taxonomical hierarchy, we have a number of actually criteria or taxon. The taxon is a unit of taxonomical hierarchy. And the taxon is any rank used in a taxonomical hierarchy. For example, we have that is phylum, class, order, genus, species, etc. So here we are arranging the organisms in a stepwise level from higher to lower levels, starting from kingdom up to species. Now in a taxonomical hierarchy, the uppermost level normally kingdom, the lowermost level is a species, and that species forms the basic unit or the fundamental unit of classification. So the kingdom, phylum, class, order, family, genus and species. Now that hierarchical system was introduced first by Linnaeus, but he introduced only phylum, class, order, just actually kingdom, class, order, genus and species. Later on only other units of taxon have been introduced. So anyway, it is a framework for assigning an organism at its particular place. For example, if you are taking frog and using that one, so it belongs to the kingdom Animalia, phylum Chordata, subphylum Vertebrata, class Amphibia, order Nura, just family Ranidae, genus Rana, and species Exarctida. So this is what is called assigning an organism at an appropriate place in a framework. In a systematic framework. This is what we call this one as a systematic framework of classification. Now, I mentioned already genus is nothing but a generic name, that is or a noun form. A species or a specific name is nothing but an adjective which describes one of the characteristics of that organism. And we are giving more importance only for the species at just the evolution level. It is more important, that's why we are giving more importance only for the species. Because evolution is always operating only at the species level. As mentioned earlier, it is not a man-made. It is a natural reality. So any species can be formed. Any species can be formed because of what is called evolution. Now, there is one question. Is any kind of subspecies interbreed with other subspecies of the same species? Normally, it is not so. So, normally, because once I say some species is formed because of the geographical isolation, so they have developed a different genotype. So, for example, it is impossible to make a cross between a frog of South India and a frog of actually just Sri Lanka. It can be done. So in random mating it is not possible. A random mating is a natural mating process. So a species actually you can make a cross between two subspecies only under abnormal conditions. Normally we can see non-random mating or assorted mating. So it is possible only non-random mating or assorted mating. For example, even in the case of species level, you can make a cross between a lion and a tiger, Asian lion, and then what is called a tigress. We are getting what is called just a liger. So it is possible, but the individual form is not fertile. It is sterile in nature. So it is possible to make a cross between two different species or two different what is called subspecies, but the resultant product is not fertile. And again, that crossing is possible only under non-random mating processes. That is what is called preferential mating, we can say, assorted mating, but not possible in natural conditions, and that mating is called random mating. In random mating, there is no crossing. That is why we can have what is called the reproductive barrier. What we call this one the reproductive isolation. So there is always reproductive isolation between two different species or two different subspecies. Now we go back to the next one. So I mentioned already the species is a basic unit. And now the term species was coined by Darwin. He was the first person and has given the name, that is species. Later, the first concept what we are following at present, what I mentioned earlier, that is Darwin of the 20th century. Ernst Mayr was the person who has given the modern concept of species. So now classification. So different methods are adapted by different scientists to classify the organisms from a simple way to complex way. Now you know that one, it was Ernst Haeckel, then Whitaker in 1959, and just again in 1977, Carl Woese. They classify the organisms into, that is, broad categories, namely the kingdoms. Even Carl Woese, he classified the bacteria into just eubacteria and archaebacteria. Okay, so these are all some of the methods. Now, different methods are adapted by different sites. So the first method of classification was given by Carolus Linnaeus. It's called the two-kingdom classification. He grouped all the organisms in this world under two categories. One is kingdom Plantae, which includes all the plants starting from unicellular to multicellular, and the second one kingdom Animalia, which includes all the animals starting from unicellular to multicellular. Then the three kingdom classification, so which includes the unicellular eukaryotes, the protista. Then we have all the plants and the animals. So we have kingdom Protista, kingdom Plantae, and kingdom Animalia. That was given by Ernst Haeckel. Two kingdom classification was given by Carolus Linnaeus, the earliest one. Now the four kingdom classification, it was given by Copeland. He classified all the organisms into four kingdom monograms. They include unicellular prokaryotes, Protista, unicellular eukaryotes, and this one Plantae, all plants, and Animalia, all the animals. So monogram includes unicellular prokaryotes, then Protista includes unicellular eukaryotes, Plantae, all the plants of multicellular type, and Animalia, all the animals of multicellular type. But the most accepted concept of classification was five kingdom classification just introduced in 1959 by Robert Whittaker. So he classified all the organisms in this world, the entire organisms in this world, into five kingdoms. One, the nonarians. The nonarians include unicellular prokaryotes. For example, you have the unicellular prokaryotes. Some of them are autotrophic, some of them are heterotrophic, even some of them are decomposing organisms. Some of them are even the earliest, simplest living organisms. The protista, which includes all the unicellular eukaryotes. For example, you have the animal protist, even the plant protist like the diatoms. Also, we have just the euglenoids and other terms. The fungi, all heterotrophic organisms without chlorophyll. Plants with chlorophyll and have the cell wall and have the ability of synthesizing food. Then the animals, they have holozoic type of nutrition or heterotypic type of nutrition, but they have no ability of synthesizing their own food. Hence, they are called heterotrophs. So, this is the major classification of Whittaker. We have studied more about this one already in botany. Now, excluding the protist, I mentioned the protista, the group, and also the nonarians. So, you have the nonarians, unicellular prokaryotes, which include a number of organisms. For example, mycoplasma, the simplest and what is called the smallest living organism in this world, mycoplasma, PPLO. We call this one as PPLO. This is the smallest and simplest living organism coming under the category of nonarians. Then we have also the bacteria. We have archaebacteria and also eubacteria. And we have some autotrophic bacteria also coming under this category. So these are some of the examples for nonarians. So this is the smallest and simplest living organism in this world, normally called as mycoplasma. Smallest and simplest living organism, Mycoplasma gallisepticum. As it causes the disease pneumonia, so it is called pleuropneumonia-like organism. Now, basically, after leaving this protist group, so I mentioned this protista includes normally animal protist like protozoans, decomposed protist like slime molds, then plant protist like diatoms. So these are the different categories: plant protist, animal protist, decomposed protist. So slime molds are decomposed protist. Amoeba is an example for animal protist. Diatoms an example for, that is, plant protist, just plant protist. And also we have an autotrophic protist, Noctiluca. It's coming under the protist Noctiluca. And an organism, Noctiluca, it is an autotrophic protist. Noctiluca. Now this animal possesses a chlorophyll. So it exhibits the characteristics of an animal and a plant. Such protists which exhibit both animal and plant characteristics are called amphibian. So the word amphibian we use for any protist which is behaving like an animal and a plant. That means having both plant and animal characteristics. Such protists are called amphibian. I have said an example of Noctiluca. It is an animal protist but having the chloroplast capable of synthesizing the food materials. So it is also called the burning of the seed. So one of the characteristics of this animal, it exhibits what is called bioluminescence. So the ability to emit light is called bioluminescence. So this animal is known for two characteristics. One, having both plant and animal characteristics, and also it releases or it exhibits bioluminescence, the ability to release or to just produce light, and that phenomenon is called bioluminescence. It comes in large numbers in sea, so it produces light just like cereal bulbs, hence called burning of the sea, because the light produced is actually just red in color. That is why it's called the burning of the sea. So this is one example, an animal protists, but having the characteristics of both plant and animal, such protists are called ambional. Now the broad system of classification. So the entire kingdom of animals are grouped under two categories. One, the parazoans, multicellular, but we have cellular level. For example, sponges. The body is made up of many cells, but the cells are not organized to form the tissues, but in the form of cells. Individual cells perform the functions. Then the subkingdom Eumetazoa. Here we have a tissue or organ or system level. The organisms have formed the tissues, organs, or the what is called the organ system. So the entire organ being actually the entire organism being developed. Now the subkingdom Eumetazoa further divided into two grades, and this is based on the nature of the symmetry or based on the nature of the body wall. Based on the nature of the symmetry, they are called radiata, and based on the nature of the body wall, they are two-layered. Hence the name Diploblastica. So examples are Cnidaria and then Ctenophora. And grade 2, this is based on the nature of the symmetry. Once again, they are bilaterally symmetrical and having three-layered body wall. Now this grade 2 Triploblastica again divided into two divisions. Now this method of division is based on the nature of the development. During embryogeny, for example, one stage is what is called the blastula, the next stage is called gastrula. Now in the case of blastula, in the case of gastrula, there is an opening. That opening is called blastopore, and through this blastopore only, so this is the blastopore, and this cavity is called archenteron. This cavity is called archenteron. That is, this is the one which later forms the digestive tract. Now, during development, in some cases, the blastopore develops into mouth. If the blastopore develops into mouth, then we have the animals are called protostomes. They are included under the category Protostomia. And another one, the Deuterostomia, what I represent the second one. So during development, the blastopore develops into anus, or the anus actually develops just near the blastopore, and the mouth is developed at the opposite end. So the first case Protostomia, the mouth is formed directly from the blastopore. The second case, the blastopore develops into anus. The mouth is formed at a later stage of development, just opposite to the anus. So the anus is formed either from the blastopore or near the blastopore. As the mouth is developed at a later stage of development, then this condition is called deuterostomia. Deutero-later. So further divisions, we have the protostomia and deuterostomia. Now based on the coelom, we have three subdivisions, and then based on just actually again the coelom, we have enterocoelomata. So we have with the coelom or for coelom or with what is called the true coelom. And I will tell you something about this one as one at a time. We will continue the next class. Thank you for listening to my lecture. Just you are welcome to ask any questions in the discussion part. Thank you.